What's going on, my peeps? What I've introduced to you before is these linear functions, and we're going to be moving on to quadratic equations. Now, a quadratic equation is, let's see, I'm going to break these up into two categories. Basically, I started you guys off on linear functions, which kind of means a line, and a nonlinear function, which kind of means a non-line. Now, I'll be honest with you, this right here is not a quadratic equation. It's actually called a cubic function, but I mean, we'll get there. But for now, I just want you to understand how to tell the difference between linear equations and nonlinear equations. Let's take a look at this. I want to find which ones are linear and which ones are nonlinear. Just by looking at the graph, you can basically tell pretty easy by observation. This one obviously is linear and this one obviously is linear. Why? Because they're lines. Why are these ones not linear? Because they are curvy. Because they have a bend to them. Does that kind of make sense? Alright. Now, let's look at the equations and kind of identify, now that we've identified which ones are linear and nonlinear, what about these equations make this thing linear and what about it makes it nonlinear? I'm going to look at this one. This one fits our form y equals mx plus b. Sorry, there we go. Now this one does not fit our form y equals mx plus b. Oh, by the way, case in point, we usually see f of x and I usually replace that with a y. But maybe if we're talking about a different function, we'll say a of x or b of x or c of x. And this right here is the same as f of x. Maybe we just want to say, okay, we've got 6 different graphs up here. We don't want to call them all f of x. So just in case you see the a of x, b of x, c of x, don't freak out. Alright, this one does not fit our form y equals mx plus b because our x in the line formula has a implied 1 by it. Basically, m times x to the first power plus b. Now, we don't ever write that x to the first power because, I mean, x to the first power is the same as x. So we just leave that part out. This equation has an x squared term. Notice that. Hence, it is a nonlinear form. Now, this equation right here, this one in the middle, this one has both an x cubed term, that would be this guy right here, and an x squared term. Also nonlinear. I want you to notice that. This one has an x squared term, nonlinear. This one has an x cubed and an x squared term, nonlinear. So basically the conclusion I would draw if I were you is I would say, alright, it's a line if the x is to the first power and that's the highest I have. But if if I have something that's not x to the first power, if I have an x squared, x cubed, x4, x5, etc., x100, then it's not a linear line. Alright, let's talk about some reflections. From part B, answer the following questions. Alright, what observations do you make about the linear graph versus the nonlinear graph? I'm just going to talk about these. Linear graphs are lines. Nonlinear graphs have curves. How is the symbolic representation of the linear graph different from the nonlinear graphs? Okay. Well, the symbolic representation, that would be these guys right here, the equations. The linear graphs have an x to the first power, whereas the nonlinear graph has x's to any other power. Divide the graphs into 3 pairs, each pair containing 2 graphs that have similar shapes. What is similar about the pairs? Okay, alright. I would put a of x and f of x together. See? Because those are lines. Now I would put c of x and d of x together. Why? Because these are U-shapey things. Now I would put b of x and e of x together because these are also curvy things. However, these curvy things have 2 bumps as opposed to c of x and d of x, which only has 1 bump. See those bumps? This one has 2. This one also has 2. It's very subtle 2, but it has 2. So that's how I would divide those two up. Alright, I think that, well, let's talk about this one real quick. Yeah, there we go. Which of these is linear and which of these is nonlinear? Alright, I'll do a couple of them. Excuse me, I'm sorry, I bumped the mic. I'll do a couple of them. I would say non-linear. I would say this is linear. You can tell because of the x to the first power right here. You can tell this is not linear because of the x squared term over here. Also non-linear. This one's totally linear. Is there a trick over here? No. Okay. This one is linear. I have a trick, one that's in my head. What is y equals 7? Let's do that. Let's graph that. Is that a linear or non-linear function? Whew. To be honest with you, I don't know the official answer on this, but here's what my answer would be. I would say that if I were to compare this to y equals mx plus b, the m in this case would be 0. So I would basically have a line that has a intercept at 7, so this is at 7, and it would have a slope of 0. Oh, I'm talking about a horizontal line here. So is this a linear function? I guess technically you could categorize that as a linear function. It's a very boring linear function. It's a straight horizontal line. But yes, technically linear function.